This video has been prepared by EPB Center team in the context of a service contract for the European Commission. This video is part of a series dealing with the basic concepts about energy performance in buildings. The video on exported energy highlighted that EN ISO 52000-1 defines two ways of accounting for exported energy. According to the resources used to generate it, this is called option A and is selected with K exported equals 0. According to the avoided use of resources by the external grid generators, this is called option B and is selected with K exported equal 1. This video gives a practical and numerical example of selecting option B, that is K exported equal 1. It is recommended that you watch the video on option A before this one to fully understand its contents. The first example is a simple building which is heated by a heat pump. This diagram shows the energy flows, starting from energy need for heating, the heat pump output, the heat pump input, and the delivered and exported energy carriers. The calculation of the energy performance is demonstrated by this table. There is one line for each delivered or exported energy carriers, plus some lines for the totals. The total is step A and the final result of the energy performance calculation. Then there is one column for each properties related to each energy carrier or each total, that is, the actual amount of delivered or exported energy, the conversion factors into non-renewable and renewable primary energy, the actual amount of non-renewable, renewable and total primary energy, as well as the renewable energy ratio. To handle option A and option B, the calculation in EN ISO 52000-1 is organized in two steps, step A and step B. The first step, that is step A, evaluates the exported energy according to the resources used to produce it. In this case, the exported energy is PV, so the conversion factor of exported energy is the same as PV delivered electricity. The result of this calculation step is the value for option A. The second step of the calculation, that is step B, goes from option A to option B, and it is turned on or off by the parameter K exported. If K exported is set to 0, then step B is turned off and is grayed out in this table, and the result for energy performance remains the same as in step A, that is option A. If K exported is set to 1, then step B is turned on and the energy performance result becomes the value for option B. Of course, if the PV production is low, then there is no exported energy and there is no difference between the result as step A and step B. The choice on K exported has no effect in the absence of exported energy. Let's increase PV production so that exported energy appears again, and let's have a closer look at step B now. To go from option A to option B, you have to first cancel the previous evaluation of exported energy, so we add a line with the opposite value here and replace it by the new evaluation. K exported is a multiplier of the difference of the two. With K exported equals 0, the difference is cancelled. With 1, it is confirmed. The amount of exported energy is the same in these two lines. The conversion factors change from PV to grid electricity, because we assume that each kilowatt-hour injected in the grid will decrease primary energy use of grid generators by the same amount needed to produce it. If connected to other systems than the grid, it must be the specific conversion factor here. This is a brute force way of seeing it. Take out one and add the other. This difference can be interpreted also as the profit of exporting energy. In fact, the exported energy has a cost of producing it using PV and produces a revenue, that is avoiding generation by the grid. And the difference between the two is a benefit, which is precisely what is explicitly calculated in step B and then multiplied by K exported. K exported equal 1, that is step B, includes the benefit of exporting energy into the energy performance of the building. We state this by saying that exported energy is part of the energy performance of the building. If we select K exported equal 1, that is option B, the energy available externally is set to 0 because the effect of exported energy is already accounted for within the building. It would be double counting if reporting again as available externally. Now let's have a look at the consequences of option B on the potential value of energy performance indicators. Let's start with no exported energy. The option about K exported has no effect on energy performance until electricity is completely provided by PV and there is no non-renewable primary energy used and the renewable energy ratio is 1. As soon as exported energy appears, the non-renewable energy becomes negative. This is okay. It means that the operation of the system reduces the global use of non-renewable primary energy of the world. The renewable energy ratio becomes higher than 1. That's okay. It means that we are using more renewable energy than needed in our building. If we further increase the exported energy, we will arrive at a point where the total primary energy as well is negative and the renewable energy ratio becomes negative. This is okay as well, even though it is a little bit more complicated to illustrate what's the meaning of this. Now let's have a look at a second example, a gas boiler. The diagram shows the energy flow and the table demonstrates the primary energy and renewable energy ratio calculation, as in the heat pump example. Building needs are the same, but the main energy carrier is now natural gas. PV electricity first contributes to auxiliaries as shown. Selecting option A or selecting option B has no influence on energy performance in these conditions, because there is no exported energy. If PV production exceeds the use in the building, the excess electricity is now exported. With option A, that is K exported equals 0, the increasing exported energy does not influence the energy performance. With option B, that is K exported equal 1, the avoided primary energy of the grid generators thanks to exported electricity compensates the primary energy of the gas. So you may reach a good energy performance, low primary energy, even though you still need a lot of gas to heat your building. If PV is enough, you may change the sign of energy performance and the renewable energy ratio becomes higher than 1. Since the total of non-renewable primary energy is unique, there is cross-compensation between different delivered and exported energy carriers. This is an intrinsic consequence of K exported equal 1 option, that is option B. If you want to avoid this, you have to choose K exported equals 0, that is option A, which is the same as saying discard energy produced on site, which is not used in the building. And here is a brief summary. EN ISO 52000-1 defines two ways to account for exported energy. K exported equals 0, also known as step A or option A. In this case, exported energy is not part of the energy performance of your building. The energy performance, except for special cases, is always a positive number. The renewable energy ratio is always between 0 and 1. Energy carriers are independent. See the dedicated video for details about this option. K exported equal 1, also known as step B or option B. Exported energy is part of the energy performance of your building. Energy performance can be a negative number, renewable energy ratio can be negative or higher than 1, and there can be cross-compensation between different energy carriers that are exported and delivered. Both approaches are valid. The choice between option A and option B by your country is free, but it has consequences on the energy performance value indeed. EN ISO 52000-1 makes this choice fully transparent. This video has been produced under a service contract with the European Union, represented by the European Commission. The information and views set out in this document are those of the authors and do not necessarily reflect the official opinion of the European Union. Neither the European Union, institutions and bodies, nor any person acting on their behalf may be held responsible for the use which may be made of the information contained therein.